Hey everybody, thanks for joining. I'm Geoff Shoupp. I run the Vulnerability Management program at Ohio State, and I'm going to be talking about moving from test to tamper-resistant applications. So really what we're trying to do is do security with every push without slowing development down. That's really the big key to being able to move fast and be secure. Is integrating security within your development process without getting in the way. I think that's the biggest point is I don't want to get in your way. I want to alert you to certain facts, but not necessarily stop you from deploying. So we're going to really quickly go over how to set this up using GitLab Ultimate, or as most of you know it, University Code Repository, or UCR, or Euchre, or go.osu.edu. Take your pick. So first, we're going to quickly go over creating a project, what that means. Then we're going to go over runners, linking runners to our projects, then making pipelines, customizing those pipelines, and reviewing results. So easy 5-step process. So first, we're going to go over how to use runners. Runners are really there to help build, compile, push, test, deploy your code. Think of it as a little helper is what it really is. It pulls down your project. You give it certain tasks to do, like build this thing, compile this thing, and then you can task it to push those binaries or websites anywhere you want. Real quick, the model that the runner has with GitLab is the runner is like a daemon. It's just this little service that's running, and it periodically checks with code to see if it has any tasks to do. So runners can really be run anywhere that has an internet connection to osu.edu. There's a caveat here, and we need to think securely. So just because a runner can run somewhere doesn't mean it should run somewhere. These runners really do pull down your code. So if your code is sensitive in any way or touches sensitive systems, you may want to think where these runners run, because data will be flowing to them in these pipelines. So just something to keep in mind when you're setting this up. You want secure environments. You don't want to just put runners anywhere. Okay, so now we will test out linking a runner. So here I'm in code.osu.edu. I've created this little project in here. We've used Shoupp. Some of you may know Shoupp. It's an OWASP product that they made. It's intentionally insecure, which is a good example to show what you can catch with these pipelines that we're going to use. To get this started, first we go to settings and then CI/CD and then runners. And here is all the information you'd ever want about runners, how to do it, all that stuff. So really good KBs on this, how to set it up, all that kind of stuff. Here you'll have a little key. This key is unique to your account, so my account, and this project. So whenever you use this thing, whenever you register a runner, it'll automatically link to this project under your name. So if this ever gets out, it's easy to reset it, right? I'm going to reset this like 20 times after this talk, so nobody gets my key. But so you grab that, and then you can go ahead and move over and register your runner. So let me grab that. And then here I just have a simple CentOS Docker image that I've installed GitLab Runner on. So register. So let's follow the instructions. I think that's it. So first prompts me, where do I want to point this runner? I want to point it at go.osu.edu. I don't think a port, no. Right, so this is the token that they gave me. A description for this runner. So it's better to be verbose than abstract. So Geoff Mac runner. I don't usually use tags. You guys can use tags if you want. If you're just getting started, I would not use tags, just for ease sake. So here's the next kind of big decision point that you should make. So when you execute a runner, it can do a bunch of different things. So if I say I want the runner to only run shell, meaning like bash, then I should select shell, and this runner will only run shell commands. That's it. For what we're going to do, we need to say Docker. We're going to be using, we're going to be compiling Docker containers. We're going to be using Docker and Docker here in a second. So we really need to set this as Docker. Here I say Docker latest. All of this is configurable after the fact. If you go to etc GitLab runner, you have a config.toml, and all of this can be edited in here. Here you can see the name, where I'm pointing at, that, execute, all that kind of stuff, right? So now that I have this up and running, it should be reaching out to code. And I should be able to see, yeah, there it is. I haven't run it yet, so it is checking into code, but as you can see, there's a little thing here. As soon as I set off a pipeline, it'll fully bake on and come full circle. I'm actually going to use this one because it's not running on my Mac, and I feel more comfortable using it here. But just a really quick rundown of like how all that works and what you should do. So cool. All right, we have a runner now. It should be checking in, and we should be ready. So now let's set up CI. CI is short for continuous integration. You probably hear it along continuous integration, continuous deployment. We're kind of leaving out the deployment part, at least for this talk. We're really integrating security into how we build our app. Really quick overview of continuous integration within GitLab. It's written in YAML, yet another markup language. There's a file. It's called gitlab-ci.yaml. I think you can use YAML. I always use the shorter abbreviation, just YAML. It's stored in the root of your project. And what it does is it defines stages for your pipeline. Each stage has basically 3 components. There's a script portion, what you actually want the stage to do. There's a before script. So if you need to set up anything, do anything before the actual main script runs, you can run it in your before script. There's also an after script to do any cleanup or delete anything that you need. What's cool about GitLab is they allow for templatization of pipelines. So you can define one for your team, for multiple teams, hand it out, and use it as, you just include it in your pipeline. So luckily, GitLab has graciously given us a bunch of templates for security that are crazy easy to include in your project. So let's go over it. Here, let me close out of that. Here it is. I'll zoom in a little bit. So here is my pipeline for the OWASP Juice project. In it, I define image, some variables up top that I'm going to use later. So this is my Docker image. This is basically the same Docker image, but tagged with latest. Here's a website I'm going to use for dynamic scanning. This pipeline relies on Docker. So I just specified the services it's using. And here is our first stage that we're going to tell the runner to execute. This line right here can be anything you want. I don't believe it allows for spaces. There's some syntax in here, but again, I like being verbose. So here I'm calling this build container. These stages are set by GitLab. You can reference them in the documentation to see kind of what each one does, but this is a build stage for us. And here is my script. So I'm going to log into go.osu.edu with the job token and registry. I'm going to build the juice, the vulnerable juice Docker container. I'm going to push it to the registry. Next, really, we're going to skip this for right now and go down here. So here are the templates that GitLab gives you just out of the box. So we have one for container scanning. We have one for dynamic scanning, dependency scanning, license scanning, and static code scanning. To kind of get a feel, actually, let me copy everything. To kind of get a feel of what this is doing, you can use this nifty little thing. So you go to CI/CD pipelines. As you can see, I've been testing a lot. There's this little button over here called CI Lint. So you just copy paste in there and you hit validate. What this is going to do is it's going to go down, make sure your YAML's correct. If you're new with the YAML, it's going to take a few times to get it. But what it'll do is tell you exactly what it's going to try and do. So here's the login part. Here is the container scanning portion. And it'll expand and show you what that template's actually doing. This is what the template has inside of it. So it looks like a few things, and then eventually it runs the dependency scanning. Okay, so this is dependency scanning, yeah. And I can tell it's a test job. Test. So running stuff. Here's static code analysis. If you ever want to, really what I use this for is if I don't want to use a template, if I want to really run the code, I can go in here and grab this. This is basically the way they have it set up is this up here is the before script. This right here is the script, and this right here is the after script. So you can see everybody has three, but most don't have before or after scripts. They just have the script, right? So here, I wanted to explain, here's our dynamic scanning. So this is coming from the template. And I actually injected this portion in here. And I did that right here. So each of these has a name. I think actually you can just use this all lowercase as the job name. And you can insert before and after scripts to do whatever you want. So what this before script is doing for dynamic scanning is it's actually inserting the Swagger document. So the open API, I think it's V2. So that's why it's called Swagger still. But OWASP Juice provides a Swagger document for us, and DAST will actually help scan our APIs, which is super cool. The only caveat is the dynamic scanner, ZAP, is what it's using. ZAP needs to be told where it is and given that data. So that's what this is really doing. I'm making a specific folder called zap WRK or work, and I'm copying the Swagger document in there for desks to then consume and scan. So that's it for the basic pipeline. Now, you would obviously have more stages in here, depending on your area. You would actually build your product or your application, and then probably just include these, whichever ones you actually need. If you're not using containers, you don't need to scan for containers. If you're not doing websites, you don't need dynamic scanning. But these three are pretty standard. So let me go ahead and push, and let's see what happens. Cut right here.
Fine.
Okay, so we just pushed our code, up-to-date code. Through movie magic, we let the pipeline run. This takes like 18 minutes to run, so didn't want to sit here and wait. Although that would be super fun. No, thank you. So what did it do? It took our build phase. So if you remember our build phase, and did it. So we can actually see the output from the GitLab runner. There's a lot, but here it is. It's running on the GitLab runner. It does our stuff, right? Here's the login part, the build part, and you can collapse these two. Here's the build part, and here's it building. Because this is NPM, like our website, it's huge. It's so big. And then finally, it pushes it to the repository that it's already logged into, and it gives us a little job succeeded. So we go back to our pipelines and our latest pipe pass. So here you can see in the testing phase, it did container scanning, dependency scanning, license scanning, static code analysis, dynamic scanning. And each of these stages produces what's called an artifact down at the bottom. So let's pull it up and see. Here you can see it's usually named something like GitLab dash whatever we just did dash report.json. So upload it. You can see over here that there is an artifact. You can't download it here, but you can see that it exists. So for each of these 5 tests that we have, it produces a JSON file that's then automatically uploaded into GitLab. Cool. So neat. So feel free to play around with this. Use the CI lint to actually see what the template's doing. And then either just use the template itself or grab that code from the CI lint and you can alter it to fit your needs. If you want to add more steps, remove some steps, feel free. It's all there. Each of these templates has like a ton of variables that you can supply to it up top. So here's a good example. The dynamic plugin needs a website to point at to scan. So here, OS provides this demo site. This could be your test site. It could be prod if you're feeling brave. But it just needs some website. So up here in the variables, I define that. But there are a lot of other variables for each of these. So yeah. Okay. So now that we've demoed that, let's view the results. Let's see what it picked up and see what we can do about it. So one note of clarity, you can see each of these passed. So you might naturally assume that no vulnerabilities were found. That's not what happened. There were a ton of vulnerabilities found. What these pass really tell you is that the script succeeded and nothing went wrong in gathering that data. What this also tells you is that it's not going to prevent you pushing code to the repository. So when I push code to, let's say, master branch, you may have it set up so that you have to pass unit testing or integration testing before it'll actually be accepted in the master. For these scans, none of that. It just wants the script run, and if it does, cool. If it doesn't, then it'll give you a little thing. Actually, I can show you because it'll give you this kind of yellow amber color showing like something messed up. And I can actually show you, this actually happens a lot. Right here, right? We kind of filled up my server, so it failed. But again, it didn't stop my pipeline. It just kind of skipped over it. So that's where security is really trying to get out of the way. We're not trying to stop it. We just want to record it so you know and we know. Here. So this is what it found. I was expecting to find a bunch of vulnerabilities from this really vulnerable website. And here's a breakdown of everything it found. 65 pages worth of stuff. So awesome. Here you can see just a high level breakdown. There's 4 criticals, 4 highs, all that kind of stuff. Here we can really break down into what did static code find. So static only found 4 criticals. So the main 4 criticals that we have. All right, what did it find? So in here, I'm going to guess that, so an RSA private key detected. Okay, so let's see where that's at. If we just click that, it'll open a new tab. So in here, so lib and secure.js. Oh, look at that. Begin RSA private key, blah, 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 blah. All right, so that one's legit, right? I need to take care of that. So I can either create an issue right now, fix it, push it to code, rescan it, should be good. That's cool. All right, what else did we find? All right, generic secret, let's see. Oh no, cool. So most of these I'm gonna guess are real. They're intentional, so most of them are going to be real. But let's just pretend I want to talk about it. I can comment here, right? So this isn't real. So I can comment and dismiss it. And now you see that it's gone. So I can also undo it. Yeah, so here you can really see what's cool is they also give you like the OWASP common weakness enumeration. So this helps determine the severity of what it just found. So cross-domain misconfiguration is this. It has a medium vulnerability, and it tells you exactly how to fix it. So yeah, overly permissive CORS, the cross-origin policy. So you can fix it. You at least can track everything in here, which is pretty cool. So actually, let's see it. Right? That's extremely permissive. It's basically allowing anything from anybody except for FTP. So that's pretty cool. So in here, we can also do multiple. So I think that one's pretty funny. Won't fix except risk, no reason. So I can just blatantly dismiss them. Now I do believe this is recorded. If I can go and find them. So if I don't hide dismissed, right? This will still show up, and I can get information like I did this. So you get a nice timestamp of who did what, why did at least some reason. You'll at least get their name.number for why they did that. So if you're ever curious. Yeah, so I know there's a lot here. There is some unknowns. It just couldn't tell. So those may be actually true false positives. They're not really flagged as anything. These mostly come from linting. It wasn't either able to parse it or something like that. So those, yeah, can be annoying. So I would honestly just filter those out. So criticals, highs. I would really just care about criticals, highs from all reports. Yeah, so another cool thing it does is license compliance. So it'll tell you which licenses like you should not allow, either because I could be wrong, but the GNU public license, it like your code has to remain open source. Period. You can never have a private repository. So most people don't want that. Most people shouldn't have that. So here we're actively preventing against that. But here it detected all the ones that we're actually using in our stuff. So here it would be good to review these just to make sure what you're liable for, what you're agreeing to when you download public code. Some of these, most of these are okay, but it wouldn't be a bad idea to review these time to time. What we saw was fairly easy to implement, not difficult at all. Some barriers to entry, like one right off the bat I can think of is runners. You have to have a runner to do any of this. While it's extremely easy to set up, as you saw, you do need a secure, trusted place to run it. That is first and foremost. So having a little Linux server that only connects to go.osu.edu and maybe updates, that would be the ideal place. Something that very few people have access to. An admin that kind of controls what runners run on your thing. You could invite someone to run a runner on your server and they could do nefarious things. So trusting who's on your runner, trusting that they're going to do the right thing, and not kind of goof around on your server would be a good idea. As you saw, CI Lint is a big help. Not only getting going with the YAML setup, the configuration, but also seeing what the templates are actually doing. And that applies to any templates you create on your own. So if you want to create your own template, you can see what it's doing as well in there. And as we saw, the data that's returned from those stages are artifacts, and those artifacts have sensitive data. They're real vulnerabilities against your code. So treat it as a need-to-know basis, right? I wouldn't be broadcasting I have all these critical vulnerabilities for my website that's publicly facing, so you shouldn't either, right? So just treat it as a need-to-know basis. Realize where your data is going. Think about where your data is going before you start any of this, and keep it in mind as you go. But again, super easy. Anybody that has access to code.osu.edu has access to do this. You just need to set up a runner. So, yeah, thanks for watching. Again, name's Geoff Shoupp. If you want to contact, my email address is there. As long as if you want to have any general questions, feel free to shoot vulnerabilities at an email. If you guys run into any issues trying to set this up or just want to talk about it, I'm totally open for that too. You can hit me up on Teams. I'm usually on there a lot, or email me, or we can set up a meeting too. It's fine with me. Thanks, everybody.